Okay, so we talk about triple DAS. So we have seen that DAS has some problems. The DAS is broken. So DAS has some issues with the S boxes. Those are not. I mean, some non-linearity problem. We'll see those details. But DAS is broke. I mean, and the main problem was the key size is just a 56 bit. So that is also a security issues in terms of the exhaustive search attack. So we can mount the generic attack on DAS. So DAS is broke. So now we need to have a replacement of DAS. So DAS. So people thought of that time to, instead of building a new block cipher, so why don't you try to use the DAS and have a new block cipher which could be better than DAS. So this is called triple DAS. So basically idea is we will use the DAS 3 times. So this is the triple DAS encryption. So here we have key is basically key has 2 parts, K1 and K2. So the here key size is, so each is 56 bit. So it is basically 112 bits. This is the key size for triple DAS. So we just break the key into 2 parts. This is 56 bit and this is 56 bit. Basically we want to use the DAS. So this is the plain text X. Now we apply the DAS encryption. Encryption of DAS with the key K1 and then followed by a decryption of DAS. This is the DAS decryption with the K2 and then we will use the DAS encryption again with K1 and finally we got the Y, the ciphertext. So this is the triple DAS encryption. So we have a key K which we are which is basically K1 and K2 concatenation. So this is the input. So this is the block cipher. So this is the block cipher. This is the encryption of triple DAS. Encryption of triple DAS. This is called triple DAS because we are using DAS 3 times. Okay. So now, and the key size is okay. Key size is reasonable. K. Key size is, size of the key is 112 bit. So it is difficult to think of the exhaustive search attack even if we have many processors. So parallel compare, even the time memory trade off attack would not be possible for this. So now what is the number of rounds over here? R, because for each of these DAS is having, each of these DAS encryption, decryption, encryption, each are having basically 16 round. So basically total we have 48 round. No, the 16. So this total we have, yeah. So 48 rounds. Okay. So 16 into 3. So 32 plus 16. So 48 rounds. So that is a major drawback of this attempt, because it is a huge time. 48 round block cipher. Nobody will be accepting this. So because each DAS round is a little complicated in the sense that it is having those S boxes which is not properly documented how it is coming, and moreover there are another issues that non-generic attacks. Those non-generic attack can be mounted on DAS. DAS is broke by differential attack, linear attack. So those type of attack can also be mounted here. one can think of that, because this is basically underlying block cipher is DES. So, if DES is broke by the differential attack, linear attack, so one can think of those attack on this triple DES. Okay. So, this is the encryption. So, what is the decryption? Decryption is just we have y is the input. So, for decryption we have to start from here, we should get back x. So, we have to reach here. So, for that we will use the DES decryption using the key k1. So, this is the DES decryption using the key k1, then we reach here, then we are using decryption. So, we have to use encryption. Encryption is the inverse process of decryption. So, DES encryption with the key k2. So, this will reach us here. Now, we have a encryption. So, we have to use decryption using the same key k1. So, that we will come back to the x. So, this is the decryption of DES using this k1, and we will get back this x. So, this is the decryption process of triple DES. Okay. So, this is the, so we have the key input, key is k1 XOR k2, I mean concatenate with k2. So, this is the decryption of triple DES, but it is not very interesting in a sense that number of round is more, and also the generic attack can be mounted on this. So, people did not like it very much. So, they wanted to have a replacement. So, now DES is replaced by AES, Advanced Encryption Standard, that is the Rindel. We will talk about Rindel in few later lecture. Okay. So, this is the block cipher triple DES, which is basically a 64-bit block cipher, and the key size is 112, and the ciphertext is 64-bit. So, this is the plain text, this is triple DES, and this is ciphertext, and this is the key. But inside we have 48 rounds. That is the major problem with this, because we are using 3 times DES. Okay. Okay. So, next we will talk about modes of operation on block cipher. Okay. So, this is under symmetric key crypto system. So, Alice and Bob, they are communicating with each other, and they have a common key k, that is the secret key they have. Now, suppose Alice is having a plain text, which is a long plain text, a long message. Okay. This is the message, this is the plain text M or the message. Now, suppose Alice they want to use the block cipher for their encryption purpose. So, they have a block cipher. So, they have a say L bit block cipher, L bit block cipher with the key size is same key. So, this could be DES, AES, SPN depending on L. I mean, if it is DES, L is 64-bit, if it is AES, L is 128-bit. So, but they have a block cipher, they agreed with the block cipher, and then they want to use this block cipher for their for encrypting this message M. So, what Alice will do? So, Alice will break this into L bit blocks like this. So, last block may not be L bit, maybe we have to append some dummy bit over there to in order to apply this block cipher. So, then so this is L bit. So, now we can very well apply this block cipher. Our block cipher, we use K, the key, and this. So, this is say x1, x2, x3 dot 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 something like that. So, this is y1. Okay, so on this also using the same key K. This is basically block cipher, same block cipher, and this is y2 K, this is y3. This could be ds or AES depending on the size of L. Okay, so this is the block cipher. This is block cipher encryption. So, we get this y1, y2, yn. So, this is the encryption, and Alice send this y1 concatenate y2 concatenate y3 to Bob, and Alice mentioned the length of this message. So, what Bob will do? How Bob can decrypt it? So, Bob has this y1 y2 like this. So, Bob will do the this is the encryption. Bob will do the decryption of the block cipher using the same key. Bob will get back x1. Bob will use the same key for decrypting this block cipher decryption. If it is DES, then DES decryption algorithm we have to use. If it is AES, then AES encryption we have to use there, and AES decryption we have to use. So, this is a general things. It could be any block cipher like this. So, this is the way Bob will get back the message. So, this is one way of this is one mode of operation. This is called ECB. ECB, or it is called electronic code book mode. Electronic code book mode. Okay, so this is basically using the just basically. So, can you go to the slide please? Yeah. So, this is basically we are breaking the plain text into blocks depending on the size of our block cipher, and we are using the same key, and we are encrypting these blocks parallelly, separately, simultaneously, and then we get the ciphertext C1, C2, Cn. So, this is the ciphertext. So, we concatenate this C1, C2, Cn, and we got the ciphertext. Now, this Alice is doing this. This is the encryption of these modes of operation. And now, how Bob will get back? Bob is getting this C1, C2, Cn. So, Bob will using the decryption of that particular block cipher using the same key, and Bob will get back this plain text. Okay. So, this method has a problem. This method has a problem in a sense that if we suppose our input is this image. Okay, suppose this is our input. This we have taken from Wikipedia. This picture is there in the Wikipedia. So, we have taken this picture from this is a penguin picture. So, suppose this is our plain text, just a penguin picture .jpg. Okay. Now, if we encrypt using our using our ECB modes of operation, then we are getting the output like this. I mean, this is if we apply the ECB modes of operation, and we are getting this output, the penguin, this picture. So, can you go to the slide please? So, this picture. So, is this secured? Because by seeing this picture we can easily guess that this was the picture of the penguin. So, this is not secure. So, why it is happening? Because in the image, so if we partition this into the pixel values, and we are taking some, so these are pixel values, we are taking some blocks and we are encrypting and we are generating this ciphertext block. So, but if that block is having same value, then the ciphertext block will get the same value. So, that is why the borderline, that is why this picture is coming like this. Okay. But this is not a secured encryption, because we can, anyone can guess that this was a penguin. Okay. So, now we want to do something more in the modes of operation to avoid this problem. Next mode of operation is CBC modes of operation. So, this is called Cipher Block Chaining. Block chaining, CBC. Okay. So, here what we are doing, we have the this is the plain text in a x1, x2, xn form. So, we are just XORing, this is one IV, this is called initialization vector or starting variable. This is called initialization vector or the starting variables, because we have to start with something, starting variable. Okay. So, then this we encrypt using our underlying block cipher. It could be DES, AES depending on the size of this. So, this is E of k, the block cipher encryption. Encryption of this block cipher or DES, or it could be anything, any block cipher of that size, using the same key which is shared between Alice and Bob, and we get the Y1, and this Y1 will give the feedback over here in order to avoid that penguin picture, because if we give the feedback, then it will not give us the same value for the same input. So, then we encrypt this using the same key and get the Y2. Again this Y2 we will put it here and we encrypt this and get Y3. So, this way dot dot dot. So, this is the encryption, this is the CBC encryption. This is Alice is doing, and Alice is generating this Y1, Y2 and send it to Bob. Now, Bob also has to get back this message. So, Bob is receiving this Y1, Y2, Y3 like this. So, now the question is how Bob will get back this x1, x2, x3. So, Bob has to reverse this. So, Bob is having Y1, to get back x1, what Bob has to do? Bob has to decrypt it, Bob has to go back here, then Bob has to XOR with this. So, it will cancel out, we will get the x1. So, let us try that. So, we will first decrypt it d of k using the same k, and this will XOR with this IV for the first block, and this is our x1. And for the second block, so this is a Y2, and for the second block we just second blocks means y2. So, if we decrypt it, we are here. Now, this has to be XOR with this y1 to get back the x2. So, we decrypt it using the same key. So, we reach here. Now, we have to XOR with this y1, and this will give us x2. Similarly, y3 dk. So, this is with the same key. We have to use the same key. This is basically this one. This is x3 dot 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 dot. So, this is the CBC decryption. Okay. Now, if we use this, then the penguin, this, if this is the, can you go to the slide please? If this is the image or this is the input, then the output will be, so if this is the input and if we use the CBC encryption, then the output will be this one, because it is just taking the feedback and it is giving us the this image. This image is the output of the CBC modes of operation after encryption. So, this is perfectly secure, because we cannot guess it was penguin. Okay. So, this is one modes of operation where we are taking the feedback to avoid that scenario. Now, another two modes of operation we will discuss. One is CFB, yeah. So, let me just check whether I have the picture for CBC. Yeah. So, can you please go to the slide? Yeah. So, this is the CBC modes of operation encryption. So, we have the blocks, plain text blocks x1, x2 like this. So, this is the starting vector or the initialization vector. We just XOR with this and then we encrypt using the keys shared between Alice and Bob, and then we get the y1. Then this y1 we are taking the feedback to this, and then we XOR with this x2 and encrypt using the same key we are using y2 like this. So, this is the encryption what we have discussed, and this is the corresponding decryption. So, we are taking this y1 y2 y1, then we decrypt it using the same key, and we are using this IV XORing x1 we are getting, then y2 we are decrypting IV, this we are getting. Okay. So, this is the one mode of operation. Now, we will talk about another mode of operation which is called CFB. So, this is the Cipher feedback mode. CFB. Okay. So, here what we are doing, we have this x1, x2 like this. So, we are just encrypting. So, this is the encryption using the same key. First we are encrypting the IV and then we are XORing with this and get the y1, and in the next step we are encrypting this EK using the same key, and then we are XORing this with x2 and we get y2. So, like this. So, this is encryption of CFB modes of operation. Okay. Now, how to decrypt? Decryption is basically we have given y1, y2 so on, and we have to get back the message x1, x2, xn. So, what we do from y1, how we can get x1? So, basically again we have to encrypt this, we have to encrypt this, we have to encrypt this EK using the same key, and then we XOR this with the Y1. So, this will give us X1, and now again to get back X2 we have to encrypt this Y1 again and XOR with the Y2 to get back X2. So, that is basically we are encrypting this E of k, and then we are XORing this with Y2 and we get back X2. So, this way we continue. So, this is the decryption. This is the decryption of this CFB modes of operation. Let me see whether I have picture or not. Yeah. So, can you please go to the slide? So, this is the CFB mode of operation. So, we have this messages or plain text we are making into the blocks. So, this is the initialization vector we are encrypting, then we are XORing, then we are getting Y1, then again Y1 we are encrypting. So, here we are using only the encryption, we are not decrypting the block cipher, we are not using the decryption of the block cipher. So, this is the CFB encryption, and similarly CFB decryption is this one. So, basically we are using only the encryption. Okay. So, we are not using the decryption. So, next operation is OFB output feedback mode. Okay, so OFB output feedback mode. Okay, so encryption is basically we have this IV using the same key we are using. So, this we are XORing with the plain text X1, and we are getting the Y1, and here this encryption we are taking this and this we are XORing with X2, and this is our Y2 like this. Okay. So, again this is we are encrypting using the same key, key is same, this is the block cipher. So, key has to be same, that key is shared between Alice and Bob. So, this we are encrypting with X3. So, this is basically Y3 and so on. So, this is the encryption. Okay, and then the decryption will be, we have given this Y1, Y2, Y so on, and we have to get back this X. So, how to get X1? X1 is basically we have to again encrypt, we have to get this, then if we XOR with this we will get X1. So, that we have to write. So, this is the IV we are encrypting using the same key, and this we are, so we reach here. So, this we have to XOR with Y1, and this will give us X1. So, similar way this is EK, and this will keep it here, and this will XOR with Y2, we will get X2 dot dot dot. So, this is the decryption of OFB modes of operation. So, just we will use the reverse process. Now, there is another mode of operation which is called counter mode of operation or CTR. So, in CTR we just use a counter. So, we can set some counter, then this is counter plus 1, counter plus n, something like that. So, depending on how many blocks we have. So, we partition into the block. So, we just encrypt this counter, then the output we XOR with this P1, the first block of the plain text, and then we get C1, and then similarly we will do like this, we get C2 and so on. So, this is the counter mode of operation encryption. Now, for decryption we have to do the reverse. We have given this C1s and we have to get back this P1s. So, we just do the same encryption process and then we XOR with this C1 to get the P1 and this we XOR with C2 to get the P2 like this. So, this is the counter mode of operation. Okay, so thank you.